Okay, section 2.5, polynomial and rational inequalities. Probably one of my more favorite sections just because it requires some thinking, and if you know how to graph, these become very, very, very simple, and I'll show you that as we work through this. So, okay, we have x plus 4 and 2x minus 3, and they want to know when is that less than or equal to 0. And they say solve each quadratic inequality, and then we're going to graph the solutions on a number line. Okay, so it's solved. It's solved for 0, and we have two zeros. We have x equals -4. So x equals -4. And put a 0 here, and x equals positive 3/2. So there are our zeros, and basically what we're going to do here, because this is parabolic, meaning that if I factored all of this out, I would get some trinomial. So this is going to be the first term is going to be, what, 2x squared. So I know that it's going to open upward. Let me just draw a little graph here. I know that it's going to open upward. I know that it is parabolic in shape. And I know that it is going to be broader. Or narrower, sorry, narrower. It's going to be a shrink. Because it's going, this values are going to approach the y-axis. And had it been 1/2, they would be broader, or a stretch, and this value would approach the line y equals 0, or the x-axis. So x's and y's, and let's see. Okay, so what we're going to do here is, you can think of this as there's a separation. We want to know what's happening to the left, in between, to the left of -4, in between -4 and 0, from 0 to 3/2, and then from 3/2 off to infinity. So on the left side of -4, what we can do is think about a really, really, really big negative number. So I'm talking like huge, like negative infinity. So if I take negative infinity and I add 4 to it, it's probably not going to make a difference. It'd be like if I owed you $1 million. I was like, hey, I got $4 to give you today. You're probably going to look at me funny and be like, dude, really? So you can see that 4, it just doesn't even matter. So you can literally pretty much just like get rid of it. It's gone. So we just have negative infinity. And we're going to take that really big negative number and we're going to multiply it by this guy. Now again, if I took a really big negative number, that same $1 million, and I doubled it, so now I owe you $2 million. And I borrow 3 more. Is it really going to matter? I'm still going to owe you $2 million. So this can kind of go away. So this is going to be really negative. Right? And we can look at this as a negative times a negative. And this value is going to be positive. Okay? From -4, at -4 it is 0. From -4 to 0, I want to know what's going on. So now what I'm going to do is I'm going to be looking, and I literally, like I said, this is just the way that I do it, and because I'm making the videos, that's the way I'm going to show. So between -4 and 0, I really want to know what's going on. And to be honest, because this is parabolic, I know it's going to cross this y-axis somewhere, as it has to. This thing has to go through a 0. So if this is -4, I know that this line, it's continuous function, so I know it has to go through here, and I know that it has to go through 3/2. So it's going to do something like this. So in between here, -4 and 0, it's not really going to do anything funky. But to get in the habit, and you're trying to show it algebraically, I would, just because when you get to rational functions or any of the weird functions, you're going to want to test them. So it's a good habit, and it's good practice. Okay, so if I take this -1 and I throw it in here, can you see that this value is going to be positive? And if I throw this same -1 in here, I'm going to get -2 minus 3. That's going to give me a negative. So this value is going to be positive times negative, so I'm going to be in the negative between -4 and 0. And then from 0 to 3/2, we have, I'm going to pick 1, and I'm going to put 1 in here. So this value is going to be positive, and then when I put this 1 in here, this is going to be 2 times 1, and then 2 minus 3 is still a negative number. So this value is still going to be negative. And then over here, we can look at this in the same light that we looked at over here. And interestingly enough, in this case, this very positive number is going to outweigh anything over here. So we'll just put that as a positive infinity. And then this guy over here is going to be 2 times positive infinity. So we have another positive infinity. And positive infinity times positive infinity is a positive times a positive, and so we're going to get a positive. So can you see that from negative infinity to -4, where it's 0, values are going to be positive? And we can look over here at this graph. Can you see that all these x values are going to hit this graph, and it's going to, when they hit it, the number for y is going to be a positive number. Between -4 and 0, these values are going to be negative. They're below the line y equals 0. So this guy, in between 0 and 3/2, again, we have values that are negative, and we showed that here. And then from this 0 off to positive infinity, these values are all positive. And can you see how I didn't need to draw like this number line? I could have just drawn this graph, and from this graph I could have picked out everything that I wanted to know. There it is. That's my 0 line. I know that it goes from here to here. So technically I could do this line graph right here, and I can say, okay, this thing goes from -4 to 3/2. And it includes it because we're at the value 0 when we are at -4, and this equal sign is why this bracket is here. So hopefully that helps to make sense. Now we're going to go ahead and do what the direction said, and we're going to graph it. So we have this number line. We have this -4. Remember, I always put my 0, and we have this 3/2. These are my zeros, and you can either put the dot to show that that is a 0 and you draw the line, or you can come down here and do the brackets, and then just make sure that if you do it this way that it's dark in here so you can see what's going on and the values that you picked. Or you can do it via, if they asked you for the interval notation, you could just do it that way. Alright, so here we go. I'm going to do another one here. Oh, and one other thing. We could have looked at this too, just to see where it hit. We could set this to 0. So when x is 0, which is right here, we got 4 times, this goes to 0, so -3. So this value here is -12. Okay. The next one is r squared plus 4r is less than 3. I do want to point something out. There's a time to graph and there's a time to do it algebraically. A lot of the times what's going to end up happening is you can graph, especially in these lower level classes. You can graph because all of the stuff works out nice. I could use the quadratic formula if I wanted to, but intuitive algebra trumps the quadratic formula, in my opinion. I would much rather do some intuitive, draw a line, pick some negatives, pick some positives, and see what happens. Or do some intuitive graphing. So okay, so we have r squared plus 4r. I guess that goes along with the same saying, like if I had a lemon, there's many ways, different ways I could cut the lemon. I could use a spoon, I could rip it open with my hands, or I could go in the drawer and get a really sharp knife. And, you know, depending upon the problem, it depends upon what the knife, you know, what the really sharp knife is, or the tool that you can use to solve it. And the more you know, the quicker you can find the sharp knife. And lastly, hindsight is always 20/20. So what I always do is after I'm done with a problem, I'll go back and look at it and say, hey, what could I have done differently? Is there another problem strategy that I could have used? Or is there some other connection that I can make to other things that I've learned to help me next time so I don't have to do all that work, because I'm quite lazy. Alright, so here we go. So here's what I know. This is a parabolic. The boss is r squared. So I know for a fact that it has to go up here, right? If I set this guy to 0, if I set this guy to 0, I get 0 plus 0 minus 3. So it crosses the y-axis at -3. And, alright, sorry about that. One of my girls got out of bed. Okay, so anyway, and what I'm basically doing here is, what I'm trying to see is, if this didn't have any zeros, or then what would end up happening is this thing would be set up here somewhere, so my y-intercept would have been a positive value, and I know that it's parabolic, so it would have been setting up here. And if it didn't have any zeros, then that means that I can't factor it. And if I can't factor it, then that tells me that all of the values from -infinity to positive infinity would have satisfied this equation. That's not the case here, because we have a y-intercept at -3. That means that somewhere it has to cross the x-axis. So I have a -0 and I have a +0. So my next step is to try to factor this polynomial and pray that it's nice. And so I have -3 and a +4. And I always write it like this. It's just me. So two numbers multiplied together that are going to give me -3. Well, that's going to be tough. So what I'm going to say is that these zeros are not round zeros. They're going to be like 1 point something to whatever. So now what I'm going to do is I am going to go ahead and use the quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2a. Let's define my a, my b, and my c. My a is 1. That's the coefficient of the squared term. My b is going to be 4. and my constant term c is equal to -3. Alright, so then it's just plug and chug. Alright, so the opposite of b is going to be -4. And then we're going to have plus or minus the square root of b squared is going to be 16. That's 4 squared. And then -4 times 1 times -3. It's going to be a positive 12. So plus 12. And this should be interesting. A -4 plus or minus the square root of 28 divided by 2 times 1 is 2. Alright. I'm just going to point out, if I can get my pen to work, that this problem, I went back and looked at the book, and I wrote it down wrong. This is supposed to be my -3, so is greater than -3, which would have made it so much easier. So this is probably going to be outside the scope of what they're attempting to teach you in this section, but it allows us to look at a couple things. So it allows us to look at the quadratic formula, which we have to anyway. And actually, I was trying to figure out where I was going to put it in, so we're just going to put it in right here. Okay, so this is going to be the square root of 28. What I'm going to do here is I'm going to find an exact value. So this is going to be, or not an exact value, but I'm going to try to break this thing apart if I can. I'm not really seeing, maybe 4 times. Well, let's just factor it. So we have 28, so we have 4 times 7. Okay, so 4 times 7. This will be divided by 2. So we have -4 plus the square root of 4 times 7. And that can be broken apart as the square root of 4. And I'm just going to do this the long way so we can see what's going on in case people forgot. So we have 4 that times the square root of 4 times the square root of 7, and the square root of 4 is 2, so we have -4 plus 2 root 7. Now, this really doesn't help me. It doesn't help me at all, except for now I can cancel this 2. So this becomes 1. Actually, it does help me. This becomes 2, and this becomes 1. Okay, well that's kind of cool. So we got -2 plus root 7, or we're going to have -2 minus root 7. Now, the square root of 7, let's look. We got the square root of 4, which is equal to 2. The next one we have is the square root of 9, which is equal to 3. So this value is in between 2 and 3. Which one is it closer to? It's going to be closer to 3. So I'm going to say that it's probably going to be like 2.6-ish. And if I take 2.6 and I multiply it by 2.6, I get 36. I get 15, 0, 2, 1, 4, 5. And then we got what, 6, 7, 6, and then 2 decimal places. So 6.76. I'm going to say that's close enough. So we're good. So 6.76. So I'm going to take a -2 and I'm going to add 6.76. And I'm going to get 4.76. So I'm going to say that one of my zeros is approximately equal to 4.76. And the other x is going to be approximately equal to negative 8.76. All right. So, man, I need more paper. I always say, give me a math problem where I need bigger paper, and I'm happy. Okay, so so these are going to be our zeros, and if we go back up here and grab our y-intercept, is at -3, and I said that that we had to have 2 zeros. Remember that? So we have -3. Our zeros are going to be, I said we had to have one negative, so -8.76, and our positive one was 4.76. And it had to pass through these 2 points, and we have to go off to positive infinity, off to negative infinity, and we have to run through this point. Now, let's see. And I do want to point out one other thing. I'm sketching this graph, but I do want you to realize that it doesn't matter for what we're doing, but it's good to get, you know, a good concept of what's going on. Because it's parabolic, we could have found the vertex, and the vertex could have been here, which would have made it go through here, but when it did its parabolic shape, it would have been like, you know, that's the vertex, and this would have been y-intercept. Notice that I have my y-intercept at the vertex, and that might not have been the case. I don't know, and I'm not going to sit here and solve the vertex to figure it out. But okay, so now we can look at this intuitively and say, okay, from the left of negative 8.76, there are positive values. These are negative, and these are positive. So we can graph a solution, and we can say, okay, this is negative 8.76, and this is an approximate solution, but you know, this is really close. And now we can look at our graph. And we can say, okay, these are positive, right? Or I'm sorry, we're graphing the solution. Okay, so from this 0 to this 0, that is when it is. I don't remember if I said greater than or less than. We want to know when it's greater than 0. So where it's greater than 0 is here and here, right? So in this area and this area. So from 476, how did it say? It didn't say equal to. So we got an open circle and an open circle, and we go off to infinity. We go back to negative infinity, or from negative infinity to this value, excluding this value. None of these values are going to satisfy the equation, and from 4.76, not including to infinity. And if I was to write this in interval notation, it would be from negative infinity to this value, negative 8.76, excluding union from 4.76 off to infinity. And these, either one of these would be an acceptable solution, or you could have this. Just make sure you darken in that area. Alright, that was a fun problem. It was a tough problem. You had to know a lot to be able to figure it out, but I think we worked through it pretty well. Alright, so now what we're going to do is we're going to look at the other version real quick. And this is more than likely like the type of problem that's going to be on the test. So this is r squared plus 4r is greater than negative 3. We're going to take it and set it equal to 0. So this will be a plus 3. And then we're going to try to factor this baby. it's going to be R and then plus 3 plus 1. Okay, so my zeros are at -3 when x equals -3 and x equals -1. Alright, sorry I got interrupted again. Okay, so my zeros are -3 and -1. And I have a y-intercept at the point 3. Okay, so what I'm going to do is I'm going to intuitively look at this. Again, if they ask you to solve it, you can use a knife, or you can use a butter knife, you can use your hands. I'm going to choose to use a really sharp knife. I'm going to say, okay, this is going to be -3, this is going to be -1. I know it has to pass through these 2 points. And actually what I'm going to do is I'm going to move my -3 over here, since it's all on one side. And I'll pop in my zeros. One there, one there. Its parent function is r squared, so it's parabolic. Again, it's going to go up and up. The y-intercept is at 3, so there's 3, and there'll be a vertex somewhere down here. If we wanted to, we could figure that out. We're going to go down through here, through this vertex, wherever it might be, up through that point, and off to infinity. So the question is when is this guy greater than 0? Remember that this is the line y equals 0. So greater than, so it's going to be anything from -infinity to -3. It's got to be greater than 0. It can't be equal to. And then we'll have a union from -1, excluding -1. Remember, it's greater than, not equal to positive infinity. So that would be the solution. And then if we wanted to graph it on a line, set my 0, even though they're both on one side, is what it is. -3. Okay, so excluding this value and excluding this value, we go to the from -1 to infinity, and from -infinity to 3. That would probably make this look a little bit neater. And these were my zeros. Or these were my zeros. All right, so algebraically, what you can do is this. So we have this line, and let's say we don't know how to graph, but what we do know is that we have a -3, a -1, and we can just intuitively do some mathematics on it, some algebra, and see what happens. So I'm going to end up with something times something. So take this and make this really big positive number from here. So really big positive number, what's going to happen? If you add 3 to it, it's still going to be a really big positive number. Over here, it's going to be the same thing. So positive times positive, you get positive. Put a really big negative number in there, and then add 3 to it, it's still going to be really negative. It seems kind of funny to say a really big negative number, but you get what I mean. Times, take that same negative number and plug it in here, a really negative number, and add 1 to it, and you get another negative. So this is going to be positive again. Pick a value in between -1 and 3, and you'll know what happens there. So between -1 and 3, I'm going to pick -2. So if I plugged it in here, this guy's bigger, so it's going to have to be negative. And then if I plug it in over here, the negative's bigger, so I'm sorry, I said this wrong. When I plug it in here, the positive is bigger, so this guy's going to be positive. And then when I plug the negative in here, -2 plus 1 is -1, so this guy's going to be negative, and positive times negative is negative. And then you can look at it and say, okay, well, from this value excluding, So from this value excluding, and from this value excluding, like that. Or you can do what we did up there, something like that. Alright, I hope that makes sense, and we'll move on to another problem. Let's see. I want to go with some green this time. Yeah, let's go green. Alright, so we have p squared minus 16 is greater than 0. If you haven't started looking for this, look for it. This is a perfect square. So we end up with p squared plus 4, I'm sorry, back this up a little bit. My brain was going to say something else and ended up messing up, which is usually what happens when I mess up. Okay, so we have p plus 4, p minus 4. So our zeros, and like I said, I'm going to graph it, and I'm going to keep doing this so that way you can see how much faster or slower it is. So I have a negative 4 and a positive 4. P squared, parent's function, is squared. It's parabolic. It has to go through these 2 points. The vertex is going to be when p is 0, so we got a negative 16, and it has to go from negative infinity, positive infinity, and we... Okay, so what's the question? When is it greater than 0? Well, it's greater than 0 everywhere that's above this line. So there and there. So we're going to graph a solution. We say, okay, this is negative 4, this is positive 4, that's 0. So it's not equal to, so we put holes there, and boom, and this way, or we could do it like this. And actually, on that other example before this, when I graphed it, I think I may have went like that, and I shouldn't have. I should have went like this. Anyway, so we have that, and we have from negative infinity to negative 4, union, from 4 to infinity. The algebra way to do it is stick negative infinity in there. See what happens. Negative infinity plus 4, still going to be negative. Take negative infinity and stick it in here, and then subtract some more. You're still going to have a negative number. So you go positive. In here, pick 0, stick it in here. That's going to be 4 positive times negative, negative. You could pick a value in here if you wanted to, but I'm just going to say that this whole thing is negative just because I know the shape of it and I know it's not going to do anything crazy. This guy over here, pick a big positive number. This remains positive. Pick a big positive number and take away 4. It won't matter. You still have a positive number. So this guy's positive. And then go back and say, okay, greater than 0. Greater than 0 means positive. So, and then you just graph it like we did. Alright, next problem. We have x cubed minus 8x, and we want to know, oh, I didn't put anything on here. How about we put less than 0? Okay, so we're going to factor out x, and we get x squared minus 8. And x squared minus 8, I'm going to use the, I forget the name of the rule. X squared is equal to 8. So basically I set it to 0, and this should be less than 0, and I technically should say less than 0. But anyway, I take the square root of both sides, and when I do, I get x is equal to plus or minus the square root of 8. The square root of 8 is really, really close to 9. So we have the square root of 4 would be 2, the square root of 9 would be 3. The square root of 8 is going to be really, 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 really close. So I'm going to say like 2.8. And if I take 2.8 and I multiply it by 2.8 and I use my calculator. I use my calculator here. 2.8 times 2.8. I get 78.4. Wait a minute. What did I do? I must have hit. Maybe this one didn't. 2.8 times 2.8. 7.84. There we go. 7.84. And if since I have a calculator right here, let's see how close I was. So 8 square root. So it wasn't 2.8, it was 2.828. But I mean, look how close my little guesstimate was. So there we go. That's going to be our guesstimate. So we're going to have x is equal to negative 7.84, x is at 0, and x is at positive 7.84. I know that it's cubic, and I'm going to go ahead and erase this other side here. I know that it's cubic, so its parent function is cubic. It's positive cubic, so it's going to have this the general shape of the cube function, x cubed, because it is cubic. So it's going to go through this point, negative 7.84, and it's going to go through 7.84, and it has to come from here and it has to go from negative infinity. So it's got to come up here and do something, and it's got to go off to positive infinity. It has no choice because it's a polynomial function, which they're amazing, because a polynomial function simply means if you could put your pen on the ground, pencil on the graph, and don't pick it up and draw it. I mean, most of them. Some of them aren't like that, like the piecewise defined functions. Okay, so here we go. I know that it has to run through this point. How high? I don't know, and I don't care. But I know it has to come back down. And I know it has to run back through this point, so it's going to come up at some point. And it's going to have to go off to infinity. So, what's the question? It wants to know when x squared minus 8x is less than 0. So it's looking for all of these values that are on the bottom. Okay, so where? Okay, well, it's in between this 0 and this 0. So I draw a line graph. And I say, okay, this is negative 7.84. This is 0, and this is 7.84. And then it says less than, so no, when it's less than 0, so at this value it's 0, at this value it's 0, at this value it's 0. So it's going to be in between these two, but not including this one and not including this one. So from 0 excluding to 7.84 excluding, these values will satisfy this equation. Algebraically, we can look at this and say, after we have our zeros, I mean, it's actually easier to graph it once you have your zeros, but I mean, algebraically, we can just look at it like this. If you took a really big negative number and stuck it in here, you take a really big negative number and you square it, you're going to get a really big positive number, and then take away 8, it's still going to be a really big positive number, times a really big negative number, so you're going to get a negative result. In between here and here, I'm going to pick like negative 1. At negative 1, I'm going to square it, I'm going to get 1 minus 8, that's going to be negative 7. Times negative. So negative times negative is going to give me a positive. And actually, I'm sorry. Just in doing this, I realized that I might have screwed this up. that's going to be a positive error, because see these values here? These values are also less than 0. So from this value, from negative infinity to this value, negative 7.84, it's going to be less than 0 also. So we have from negative infinity to negative 7.84 union. Yeah, I'm sorry about that. But glad I caught it. Because I hate trying to edit these things. Alright, so this is going to be a positive value. In between 0 and 7.86, I'm just going to choose 1. So I stick 1 in here, I square, I get negative 7. So it's a negative number times a positive number. That's going to give me a negative number. And then from this point out, it's going to be a positive squared, a really big positive squared. So this is going to be positive, and then the positive, and I get positive times positive, which is positive. So then you can see that these values are less than 0, and these values are less than 0. Alright, the next one, it wants to know when y squared is greater than 9. Well, I mean, it's not a function. And this says polynomial rational inequalities. Alright, I'll try to do some research real quick, because y squared isn't a function. If I remember correctly, y squared looks something like that, where like if you take y squared minus 9, you set that greater than 0, well, what values are going to make this true? So watch what happens. If I say, okay, what is x when y is 3? I get 0, right? But I don't only get 0. So wait, okay, so we got 3 squared minus 9. 9 minus 9 is 0, greater than 0. So at 3, we have 0. And this will be the parent function of y squared. There's a shift in here. So it's probably going to look a little different. So whatever. Let's just go ahead and plot some points. No. When x is 0, see, it's backwards. When x is 0, this y value is going to be 3. But you're going to get 2. No, see, I'm sorry. I mean, would this be one of those where you said y minus 3 plus 3? I have no idea. This is messing with my head. Anyway, I'm going to have to talk to Ms. Krause about this, because in my mind, I'm going to get 2 values. So in other words, no matter what x value I put in over here, if it's a solution-ish to the equation, I'm going to get a positive and a negative value. So it's almost like I'd have to do some type of piecewise function to even get values that work. And I could be totally wrong. So I'll ask her on Monday, and yeah. For now, what I'm going to say is y squared greater than 9. Yeah, actually, because watch what happens. If I say y squared is greater than 9, take the square root, I get y is got to be greater than plus or minus the square root of 9, which means y has to be greater than plus or minus the square root of 3, That's interesting. Okay. I'm gonna mess with that some more. I might come back. I may come back at the end and add in what I figured out. Okay, so or not. So p cubed minus 25. Let's see. P cubed minus 25 less than or equal to 0. And I think I wrote this one down wrong. It was supposed to be minus 25p. So we have p times p squared minus 25 is less than or equal to 0. And we have p times p minus 5 times p plus 5 because of that perfect square in there, less than or equal to 0. So I'm just going to graph this. So we have plus 5, minus 5, 0. It's a cubic function, so its parent function is going to be x cubed. So it's going to come from here, leave through here, and then it's going to look something like this. And this is very similar to the one that we've already done. So when I graph this, it's going to be negative 5, positive 5, and from negative infinity, notice that it says less than or equal to, so these values are okay. And then I have 0, it's just 0. And then from here, we go to positive infinity. Alright, so there are my zeros. And I'm looking at this graph. From negative infinity to negative 5, we have negative numbers. In between negative 5 and 0, we have positive numbers. From 0 to 5, we have negative numbers. And from 5 to infinity, we have positive numbers. And if you did it algebraically, you would see the same thing. So we have from negative infinity to negative 5, and we're going to include it this time. And we're going to do a union. Or did it say greater? It just said less than 0. So everywhere is negative. So in here and in between here and here. So union from 0 including to 5 including. And actually I messed up right here. So I'm gonna redraw this this graph here. 0 and 5. And where it's negative, if I'm graphing a solution, it would have to match this. I don't know if I messed up the other one or not. I'm so used to writing it in this format, and I don't ever really mess with this this line graph. Okay, so from 0 including to 5. There we go. That would be the solution, the line solution to this function. Alright, let's see. We have x plus 5 times x squared minus 2x minus 3. Okay, so we have this x plus 5. That's one of our zeros, and then I think this is going to factor pretty nice. So we have x times x gives x squared, and then we're going to have a positive 1 and a negative 3. Does that work? Negative 3 times 1 gives me negative 3. Negative 3 plus 1 gives me negative 2. Okay, that works. And then the parent function here is going to be x squared times x. So the parent function is x cubed. So I'm going to graph this as x cubed. So we have a negative 5, negative 1, and a positive 3. And we have a y-intercept, what is it, negative 15. So this would be x is 0, 0, 0, that's negative 3, 0, that's 5, 5 times negative 3 is negative 15. So we'll just put it in down here, negative 15, but it really doesn't matter. It's cubic, and it is positive cubic. So it's got to come from here, it's got to go through this point, it's got to go through this point, got to go through that point, off to infinity. And so, and I think this is probably a better way to do this. Negative 1 and 3. Okay, so what did it want to know? Oh crap, it didn't want to know anything. Okay, so when is it greater than or equal to 0? Okay, so to graph this solution, where it's greater than or equal to 0 is in between negative 5 and negative 1. So negative 5 and negative 1. And from 3 to infinity. Okay, so we have from negative 5 to negative 1, including both values, and then there's a gap, so I have a union, and then from 3 to infinity. There you go. The last one here. Okay, so we have 6, oh, this one should be fun. Plus 13x plus 5. When is that greater than 0? So I set it to 0, and let's see. What's that? 30, 10, 3, 10, 3, 13. Okay, so what I do here is this. I factor this way. You can do it any way you want. I put a 6x here and a 6x here. And I go over here and I say, okay, 6 times 5 is a positive 30. And they need to add together to give me 13. And that's 10 times 3 gives me 30, and that gives me 13. And that checks. So plus 10 plus 3. And then this is called the magic method, by the way. I'm going to factor out a 2. So 2 times 3x plus 10. And then I'm going to factor out a 3. And I get 2x plus 1. And then these guys here disappear. And interestingly enough, I don't know if it always happens, but I just noticed that since I put a 6x here and a 6x here, that the factors were 2 and a 3, and I don't know if that's has anything to do with it, but I just noticed it. Okay, so I have zeros when x is equal to negative 10/3 and when x is equal to negative 1/2. And we graph. It's parabolic. Negative 10/3 is going to be and negative 1/2. So what's this one? 3 times 3 is 9. 3 1/3. That's 23 1/3. Okay, and we want to know when this is greater than 0. So we want the top side of this graph. It's black. So we want everything from here up. I know it's a parabolic function. Just got to go up here, up here. It has a y-intercept of 5. So we put 1 at 5. 0 here, 0 here. I don't know what the vertex is, and I don't care, because it goes down to 0, or down below here. And all I want to know is where is it above and where is it below. Okay, so greater than 0 is going to be all of these values. So from negative infinity all the way to negative 10/3. We'll have a union, and we're going to go from negative 1/2. Or no, that's it. Yeah, no, it's great. Is it greater? Yeah, greater than 0. It's getting late. I've been working on this stuff all day. So we're going to go from negative 1/2, and we're going to go through to infinity. And the line graph would look like this. So I have negative 10/3, I have negative 1/2, and I have 0. And I'm going to go from, it's excluding, so these are my zeros. And then we go from here and there. And remember, if you wanted to do it the other way, you could go like this. Oh, I faced it the wrong way. This actually, I think this is the way the book does it. Alright, well that concludes 2.4. And just remember that that parent function of x squared is parabolic and it opens up. And all you have to do is figure out what happens in the middle. And that cube function goes like that. And all you have to do is figure out what happens in the middle. And the negative of it is going to make it open like this. And all you have to do is figure out what happens in the middle. And this is a reflection over the x-axis, and the negative x cubed is going to be this guy. And he's going to start up here and go through origin and come down, and this is a reflection over the y-axis, because the regular function, if you notice, it goes like this, and see how this point you could flip it over onto this one, and this one you could flip it over onto that one. Anyway, there you go.